Hello and welcome everyone. So we are discussing on soil structure interaction and this is part 2 video. In part 1 we have discussed the introduction to soil structure interaction and the consideration in case of SSI and the application of SSI, and then we have also discussed on structural response. Okay. So now in this video, part 2 video, we are going to discuss two things. One is the effects of SSI and another is the analysis of SSI. So let us begin. What are the effects of soil structure interaction? So it says the effects of SSI are more focused on its detrimental effects. So we are not going to be blinded by the false myth that SSI is only going to benefit the structure. So yeah, of course there are two benefits like increase in the time period and increase in the damping ratio, but we are focusing more on its detrimental effects. Okay, and as mentioned, even if studies have told that the design based on soil structure interaction increases the time period, and increase in time period is not always a beneficial factor. Okay, it's not always beneficial, because there is elongation of seismic waves when it is on a site of soft soil sediments. In this case, what happens, there is also increase of the natural period, hence leading to the resonance, and specifically there is resonance with the long time period vibrations. Okay, so in resonance the amplitude is magnified and that cause maximum damage, or the severity of the effect of earthquake is enhanced. So if the natural period increases, the demand for ductility also increases, because time period is increasing, so the structure has to become more ductile, and due to providing more ductility, what will happen, there will be permanent deformation and soil failure also. Both will happen, permanent deformation, soil failure. So this is the detrimental effect of SSI that will further worsen the structural seismic response. Okay, and the structure under the action of seismic force, there is interaction between the soil and foundation which brings changes in the ground motion. So here we are considering few phenomena which is under the effects of SSI. First is the kinematic interaction, second is inertial interaction, third is the soil foundation flexibility effects. Let us take the first one. In kinematic interaction, soil displacement caused by the earthquake ground motion is called as free field motion, as we have understood, and this free field motion is not followed by the foundation that is located on the soil. The kinematic interaction is caused mainly by the inability of the foundation to sink with the free field motion of the ground. So in this interaction, the foundation do not sink with the free field motion of the ground. So this is kinematic interaction between the structure and the soil. Next is the inertial interaction, and under this, the additional deformation which is caused in the soil due to transmission of inertial force to the soil by the superstructure is called as the inertial interaction. Means here the deformation which is being caused in the soil is only due to transmission of inertial force, and inertial force is coming from the superstructure to the soil. So when ground is shaking at low level, okay, and there is low level shaking, then the kinematic effects becomes more prominent. Okay, at low level, which interaction will become more prominent? Kinematic interaction, this one. Okay, because we can say that inability of the foundation will be there to sink with the free field motion, and this results in the lengthening of time period, and there is increase in radiation damping ratio. But when there is stronger shaking of the ground, then what will happen? The radiation damping is limited by the soil modulus degradation in the near field. At this situation, the inertial damping is more prominent. So at we can conclude by saying two lines. First one, we can say at lower level sacking, kinematic interaction becomes prominent. At stronger level of sacking of ground, the inertial interaction becomes prominent. So the same thing is written at this situation, the inertial damping is more prominent, and this will hence cause excessive displacement near the ground surface, and this will bring damage of the pile foundations. And the study and researches from the past and recent earthquakes show that the overall response of the structure is affected by the response from the foundation and response from the soil. And the famous example of collapse of large structure subjected to earthquake, in which SSI have become a great cause, is the Hansin Expressway in 1995 due to Kobe earthquake. And there are many other factors which we have not included here, but of course SSI becomes prominent in different cases. The third one is the stiffness and damping of the foundation. Let us discuss it. And in this case, when a vibrating structure develops some inertia force, it gives rise to these three things: moments, torsion and base shear. So when we are going to design those vibrating structure, if we are going to design, then we have to consider these forces also, which is arisen due to the vibration of the structures, because it has really a great amount of inertia. And these are the forces that brings displacement and as well as rotation in the interface between the soil and the foundation. So basically the interface between the soil and foundation will have some degree of freedom, and degree of freedom can be in sense of displacements and rotations. Okay, just like a foundation is like this. So here we consider, although it is a fixed joint, but at this interface, now this is the interface, although we consider that translation and rotation both are restrained, but due to vibration there is rise of moments, torsion and base shear. There is moment, there is base shear, there is torsion, and due to this there are displacement, linear displacement, and that can be ux, uy, uz, and there are rotation theta x, theta y and theta z. Okay, at the interface between the soil and the foundation, and the form displacement and the rotation is a result of flexibility lying in the soil and the foundation, and the flexibility is the basic reason for whole structural stability, because all these displacement and rotation are result of flexibility, and you can't make a structure rigid in case of earthquake. In earthquake, what we try to make a structure both strong as well as ductile. So ductile means what? Flexible, because a flexible structure can absorb the energy coming from the outside forces. It can absorb by deforming, but it is strong enough that it will not crack, or it will not be developing any deformation, permanent deformation. It's ductile. It will restore itself to its original position. So this flexibility is the cause of these displacement, and they are basic reason for the whole structural stability in earthquake. So these displacements has to be considered in the design in SSI. That's why SSI becomes little complex. Okay, it makes the design complex. So variations existing between the free field motion and the foundation input motions, these motions can differ because of kinematic interaction, relative displacement between foundation and free field. So all of these things is done to have deviation from the free field motion in the absence of a structure, and the foundation inertia forms the kinematic interaction, and these stiffness and damping of the foundation has to be understood in case of SSI. So now let us discuss how do we analyze the soil structure interaction. Okay, so whatever we have discussed in SSI, although it remains theoretical because the analysis process is really complex, and the process that we do follow is finite element method, and that is discussed in the upcoming courses in post graduation. But yeah, we can understand some basics, what are the methods of analyzing SSI, and they include two methods. One is the direct analysis, another is the substructure approach. This is very easy. This is basically superposition method. Okay, and this is relatively easier than the first approach, that is the finite element method. And finite element method is totally complex unless we have simple elements like triangular elements. But when you go to the real life, the elements are basically the small fragments of a bigger continuum, and elements become more and more complex, and the more complex an element become, for the entire continuum, when we go for integration for all the elements, it becomes overall complex. So that's why finite element method is basically FEM. It is called FEM. Is basically done numerically through the MATLAB or some softwares like that. Okay, it's not easy, very easy. So what is direct analysis in SSI? In this type of analysis, the soil and the structure is used in the same model for analysis. So here we consider the same model. In the same model, soil is also considered and the structure is also considered, and they are analyzed as a complete system. So we will see in the figure below that the soil system is represented as a continuum. One such example is by the representation of finite elements, the foundation, structural elements, and load transmitting boundaries. The elements at the interface located on the edges of foundation are also included. So what are different things included in this figure? You can see one is the soil elements. Okay, this soil elements, and this is here represented as a continuum. It is also a part of the model, and we have to consider the effect at all the points. So we have here fragmented the soil elements in small elements, and you may be seeing the elements in a small squares and rectangles, but they are in 3D. Okay, so this is the boundary, transmitting boundary here, med, and the foundation elements. This is the foundation elements or the interface between the foundation and the soil. Okay, and this is foundation soil interface elements. Okay, these elements are the foundation soil interface element. This is structure, and this is the acceleration. U double dot means acceleration due to earthquake, and this has three variables, that is the time. Okay, and then x axis, x components, y component, and z component, and below this soil is the bedrock. Okay, this is coordinate system here. So this is the illustration of direct analysis of SSI with the help of finite elements. So this method is rarely used in practice as it involves large computation and is very complex. As we have said, this is very complex to analyze, and it can be done basically with the help of advanced software or the programming or the coding. We can do this, but it's complex. Direct approach is really complex in analyzing SSI. So what remains is the substructure approach, and that is also known as the superposition method. And in substructure approach in SSI, we do what? That SSI activity is divided into two parts. Okay, the SSI interaction is divided into two parts, and these are latter combined to form a complete solution for the problem. So this is what? This is superposition. In superposition, what you do? You what you do, you decompose a complex problem into two simpler problems and then do the analysis and then later combine them to form the complete solution for the given problem. So in this approach also, a model is generated with certain requirements. What are those requirements? The free field motions and the corresponding soil properties is evaluated. The transfer functions are evaluated to convert the free field motion to the foundation input motion, and then springs and dashboards are incorporated, where the springs represent the stiffness and the dashboards represent the damping at the soil and the foundation interface. And the last one is the response analysis of the combined structure. Okay. So in figure below, we will see that how a general problem A is being evaluated, and the problem A is solved here in such a way it is decomposed into problem A1 plus problem A2, and in this way A1 plus A2 we can get the complete solution of problem A. So this is basically the principle of superposition, and each problem problem A1 and problem A2 is evaluated separately, and the combination of the result will give the final solution. And this is how we do if this is our problem A. So this is being here decomposed into two problem statements, problem A1 and problem A2, and this is called splitting of a problem A by superposition substructure approach. So here this is our structure, superstructure, okay, and this is our substructure, this is our soil. So when there is seismic wave in the soil, then we decompose this statement or split this problem statement into two. In the first case, you can see in this case this is the forces being shown here, and the loads is here represented by minus F. Okay, this load is from the structure to the soil. Okay, in the next statement the forces are shown in just opposite direction. Okay, this is the load F. So here load is F and here load is minus F. So that makes the total system F minus F is equal to net force is 0. And in this case the force is from the structure to the soil, and in this case the force is from the soil to the structure. And in this case we do the analysis separately and then combine them to get the final solution of SSI through the substructure approach. So although the SSI remains theoretical, but we have understood this interaction which consists of earthquake motions, which is involving three linked parameters, that is the structure, the foundation and the soil beneath the foundation, and how these three are linked in generating two responses, the structural responses and the ground responses. Structural responses are very important. They cannot be neglected all the time because of the false myth that SSI is always beneficial, especially in the three cases when the inertia is very high and the soil is very soft, and this the building is of very high rise building with high shear velocity of the soil. So in these cases SSI has to be incorporated for a safer and good conservative design of the structures. So hope this will quench the thirst for the knowledge of SSI, and this is all that we can cover which is in the scope of BTech syllabus, and hope you must have understood what is SSI, and we will be discussing if there is some topics left in the next video. Till that, stay tuned and stay safe. Thank you.